Hello everyone, in this video we will exploring two different concepts in data analysis and machine learning, multicollinearity and principal component analysis or PCA. I will explain the theory behind each concept and demonstrate how to apply them using R and Python. Let's dive right in now. Identifying multicollinearity. What is multicollinearity? First, let's look about multicollinearity. Multicollinearity happens when two or more independent variables is a data set in a data sets are highly cro- correlated. Essentially, these variables provide redundant information which makes it difficult for regressions models to estimate their individual effect accurately. The major problems caused by multicollinearity are the regression coefficients becomes unstoppable. Second, the standard error of the coefficients inflate, making them less reliable. This leads to non-significant predictor even when the overall model fit seems good. For example, if you are analyzing house prices and includes both tools area and numbers of rooms as predictors, they might be strongly correlated, causing multicollinearity. Now we will talk about how to detect multicollinearity. How to detect multicollinearity. First, we have correctly correlations matrix. Check pairwise correlation between variables. High correlations says above zero point 0.8 could singular problem. Second, we have variable inflation factor or VIF. VIF measures how much the variance of a regression coefficient increased due to multicollinearity. A VIF values above 5 or 10 is considered problematic. Mathematically, VIF is calculated as VF dash I equals to frequency 1 bracket 1 minus R square, where R square I is the coefficient of determination where the j is the variable regress on all others. Third, we have condition numbers. This is based on the single values of the covariance matrix. A condition number above 30 suggests multicollinearity. Collinearity. Now we will talk about the principal component analysis. What is PCA? PCA stands for Principal Component Analysis. PCA is a technique for dimensionality reduction. It transforms a dataset with many variables into a smaller set of un- uncorrelated variables called principal components while retaining most of the information. This is particularly helpful in cases of high dimensional data where there are too many variables to analyze efficiently. Multicollinearity exists among the variables. The principal components are ranked by how much variance they explain in the data. For instance, the principal component explain the largest variance, the second explain the largest remaining variance, and so on. Now we will talk about how PCA works. PCA works in three steps. Standardization: the data is scaled to have a mean of 0 and a variable of 1. Now second is covariance matrix calculation. This matrix show how variants are related to each other. And now third is eigenvalue decomposition. You see eigenvalue decomposition. Eigenvalue indicates the variance captured by each component, or eigenvalue qualifies variance explained by each principal component while eigenvector defines their directions. And fourth one is selecting components. We retain components that explain says 95% of the variance. Here the explained variation ratio show how much variance each component captured, and the tree plot helps decide the optimal number of components. And now we will discuss about benefit of PCA. Benefit of PCA are reduce dimensionality, specifying models, mitigates multicollinearity, improves computational efficiency and visualization. In summary, at last we will talk about multicollinearity complicates regression models by inflating variance and reducing reliability. We detect it using methods like VIF and correction. Correlation matrix. PCA helps reduce dimensionality and mitigates multicollinearity by creating uncorrelated components that retain most of the data variance. Now let's see the code we have. Demonstrate how will you identify multicollinearity Python in Python. Here is the code from states models dot states dot outliers influence import variance influence factors import pandas PD data. We have VIF and print VIF. Let's run our code. Here you can see int if demonstrate how will you apply principal component. Now second we will demonstrate how you will apply principal component analysis using Python. From sklearn.decomposition import PCA. From sklearn.preprocessing import standard scale. Import matplotlib.pyp lot as plt. Data scaled equals to standard scalar. Change n component to a value less than or single to 3. PCA equals to PCA and this, then print plt.show. Now let's run our code. You can see the graph is plotted. Understanding this concept ensure that your models are both interpretable and efficient. That's for this video. Thank you. See you in the next video.